people, and welcome. In today's video, we're going to be solving some inequalities. Now, if you're in my class, this is the first time you've seen inequality, so we're going to take it very slow and do some simple examples at first, maybe throw in a little bit more of a difficult example towards the end. Disclaimer time, I am human, so if I make a mistake, that's okay. Let me know where the mistake occurs, so that way I can learn from it. Let's go ahead and start with what an inequality is. So in an inequality, we use symbols like this. There's one symbol, there's another symbol, here's another symbol, and then here's our fourth symbol. So an inequality is something that is not equal. Okay, so there is no equal sign. Here's our thinking bubble. So inequalities, no equal sign. So I'm just going to leave no equal sign because it could potentially be equal, and I'll explain here in just a few seconds. So what are these signs? If you have had elementary school here, then you may have seen the alligator teeth. Here's another thinking bubble. So usually when we first introduce inequality signs, we see alligator teeth. And so the alligator is super duper hungry and it wants to eat the larger number. So for example, 2 and 8. The alligator wants to eat 8 because 8 is bigger. Get it? 8 because the alligator ate. It's okay. Math joke. All right. So what are these symbols called? When a symbol is pointing to the left, this symbol is called less than. If it's pointing to the right, this is called greater than. But if it has this weird looking line underneath it, that means it could be less than or equal. It could be greater than or equal. Not and. It can't be bigger and equal at the same time. It's either bigger or it can equal. Okay? So how do we solve inequalities? How does that look like? Well, let's do an example. I'm going to do a T-chart. On one of them, I'm going to write equations. And on the other one, I'm going to write inequality. And for both of them, we're going to do x is equal to 3. Another one's going to be 5n minus 6 is equal to 14. 12 is equal to 7 minus 3y. X divided by 4 minus 6 is equal to 1. And I just want to show you how it looks. So these are all equations. Notice we have an equal sign. Equation, equal, equation, equal. Now for the inequality, you can have something like x is less than or equal to 3. You can have something that says 5n minus 6 is less than 14. You can have something like 12 greater than or equal to 7 minus 3y. And you can have something like x divided by 4 minus 6 is greater than 1. So inequalities are not equal, right? It could be equal, but there is no equal sign. You have something that is greater than or less than. Some of them do have the or equals, that is the second bar on the bottom, but there is no actual equal sign. So notice the difference of how this looks. Let's do an example. And let's start with a little bit of a simpler example. Let's start with a one-step example. So example 1, 2x is less than negative 4. How do we even start this? Well, here's our thinking bubble. Pretend the inequality sign is an equals. Same step as solving an equation. So if we pretend this is an equals, what is our first step in solving an equation? Our first step in solving an equation is always do the dotted line. There it is, dotted line. What's our second step in our equations when we are solving an equation? And that is to get our variable by itself by by going backwards on PEMDAS. So I need to get x by itself. How is 2 and x attached? 2 times x. Still need to get x by itself. What is the opposite of 2 times x? I'm going to take 2, I'm going to divide by 2, bring down the x, and then this 4 is negative 4. Same step on both sides. So if I divided by 2 here, I have to divide by 2 on the other side. Still have my dotted line. Again, same steps as solving an equation. Nothing new except at the end. 2 go over 2, that's canceling out. That undoes each other. So here's x. Negative 4 divided by 2 is saying 2 times what is negative 4. If you watched my multiplication division video, then you know that because there is one negative in this whole statement, that we need a negative in here because 2 is positive. 2 times a negative is negative, so we need 2 times negative 2. So x is negative 2. Now, I already made a mistake, so I'm going to erase this because we actually don't have an equals. We're going to pretend. So at the end, you are done pretending. We're back to reality. And for our reality, we have this as our symbol, which is less than. Is x by itself? Yes. Then we are done. I'm going to quickly show you how to graph. Whenever you're graphing, your teacher might have different methods of graphing, but when we're graphing, we are graphing on a number line. So I'm going to do a quick number line here. Here it is. Now 0 does not have to be in the middle. I can put 0 right here. Our goal is to get negative 2. Negative 1, negative 2. I'm going to throw in some more dashes here on both sides of 0. Okay, I'm going to read it. I'm going to translate this. Again, like I said before, translating is super duper duper, but duper important in math. This is x is less than negative 2. So find negative 2. Here it is. And which direction is less than? Which direction is smaller than negative 2? Smaller than negative 2 is back here. Now, here's another thinking bubble. Let's actually throw in the bubble up here. Whenever you're graphing, you need to know when to bubble in or when to keep it open. If you do not have that bar underneath, you keep it open. If you do have that bar underneath, you're going to close up that circle. Again, if you have that bar underneath, you're going to close up that circle. If you do not have that bar underneath, then you leave that circle open when graphing inequalities. So do we have a bar underneath? We do not, so we leave it open. All right, let's do another example, one with 2 steps. All right, now here's super duper important information. I even took out a red Sharpie for that. If you multiply or divide by a negative, you must flip the sign. So what does flip the sign mean? Well, it means that if you have, let's see if I can do it, a sign like this, right, greater than, and you flip it, it becomes less than. However, if you have an or equals, so here's less than or equals, and you flip it like that. Oh, that's bad. Let me try it. That was embarrassing. Let me try it. So if your original is something like this, you're going to flip it to the opposite. So if this is less than, you're going to say greater than. If this is greater than, it goes to less than. If this is less than or equal to, now it's greater than or equal to. And if it is greater than or equal to, then we're going to go less than or equal to. The or equal to doesn't get flipped because it's just a line, but the symbol, the less than or greater than, those get flipped. So let's do example number 2. And we have negative 4x plus 7 greater or equal to negative 9. Again, we're treating this like an equation. So we're doing all the steps, except at the end, we're going to figure out the sign. So here's my dotted line. Our objective is to get x by itself. Here is x. When solving an equation, we're doing the reverse PEMDAS, which means we're getting rid of pluses and minuses first. I see a plus 7. I'm going to get rid of that by saying minus 7 both sides. Best part of solving an equation is this part here. You get to cross them out. Did I touch my negative 4? Did I touch my x? No, I did not. So I'm going to write negative 4 and x. This here says negative 9 and negative 17. So I have thinking bubble, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have negative 7s, 1, 2, 3, 4, 5, 6, 7. So what do I have in my thinking bubble? I have negatives. So I know it's going to be a negative something. I only have negatives. There are no zero pairs. I have a negative, but how many negatives? I have 9, 10, 11, 12, 13, 14, 15, 16 negatives. Are we done? Did we reach our goal? Nope. Here's x. It's still attached to 4. How is it attached to 4? Well, let's see. Mathematicians are what? Lazy. So we have 4 and we have x. How are they together? By times. So let's go ahead and I'm going to rewrite this one more time. But in this time, I'm going to say negative 4 and x by times. But how do we undo that? What is the opposite of that? The opposite of negative 4 times x is to divide by negative 4. So I'm going to divide by negative 4. This is where your red flag should occur. Anytime you divide by negative number or multiply, so you are dividing by a negative, you have to flip the sign. Flip the sign. So now I'm going to write flip here. So we know that we're going to flip the sign. Well, negative and negative, they go away. So those cancel out. Let me choose green because that's what we're using for canceling things out. 4 divided by 4, that is 1. That goes away. Negative and negative, that goes away. 2 negatives make a positive. So what am I left over? On my left-hand side, I'm left over with x. I'm going to write that here. On my right-hand side, this says 4 times what is 16? And we know 4 times 4 is 16, so I'm going to write 4 here as my answer. Now, this is where you need to be careful. We divided by a negative. We divided by a negative. We have to flip the sign. So our original sign was greater than or equal to. So now we have to flip the sign and make it into a less than or equal to sign. We have to flip the original sign. Now that we flip the sign, is x by itself? Yes. Did we solve the inequality? Yes. So we are done. We're putting a box around this. Let's quickly graph this on a number line. Okay, what number am I looking for? I'm looking for the number 4. 1, 2, 3, 4. I'm going to put numbers on both sides here, or tick marks. Okay, here's 4. Put a 0 on top of it, or a circle. Are we shading? Are we filling this bubble in? Do we have the or equals underneath? If we have this or equals, then we need to shade it. And in this case, yes, we do have the or equals, so I'm going to shade this in. And then which direction do we go? Do we go to the left or to the right? Well, let's translate this. X is smaller, so less than 4. So we want X is less than 4. So what numbers, this is what numbers is less than 4? Well, 3 is less than 4. 2 is also less than 4. 1 is less than 4. Negative 3 is less than 4. So we have to go to the left. All right, let's do a few more examples. I'm going to shift this paper. Then you treat this like an equation. However, if you multiply or divide by a negative, you must, absolutely must, 100% flip the sign. All right, let's actually do one. Let's do this one. It's a little bit more difficult, so this will be our last example. So we have negative 5x plus 7 is less than 2 times x minus 3. Okay, step number 1, dotted line. And I'm making this dotted line a little bit longer because I'm assuming with this type of problem, it's going to take us more steps. I'm noticing I have 2 on the outside, so I have 2 times 4 minus 3. So I'm going to distribute. I'm going to say 2 times x and 2 times negative 3. I'm circling negative 3 because it is a negative and I don't want to forget that negative. I'm not doing anything on the left-hand side. I'm going to recopy this. However, I am doing a lot on my right-hand side. So I have 2 times x, which is 2x, 2 times negative 3, which is negative 6. At this point, again, we are solving an equation-ish. We're solving an inequality, but we are pretending we're using our imagination. How would I solve this if it were an equation? And the thing that I would do is I would start to combine like terms. I see that on one side, I have an x, and I see on the other side, I have an x. I also see that I have 2 numbers that are without a letter. So I'm going to combine them as well. So which one goes where? It doesn't matter. If you want to put numbers on this side, do it. If you want to put numbers on this side, do it. If you want to put all of your letters here, do it. If you want to put all your letters here, do it. Doesn't matter. I'm choosing my way, but there are 4 different ways that you can do this. 2 different ways? No, 4 different ways that you can do this. All right, so I'm choosing this method. I'm going to get rid of this minus 5. Why? I don't know. I don't like minuses. So I'm going to say adding 5x to both sides. Notice how I'm putting my 5x right next to my 2x because they are like terms. I don't want to put my 5x next to minus 6 because they are not like terms. So I have 2 x's and I'm adding 5 more x's. 5, 6, 7. That means I have 7 x's total. I didn't do anything with my plus 7 on this side, so I'm going to bring my plus 7 on this. You can leave the plus if you want. You don't have to. I also didn't do anything with my minus 6, so I have to bring down the minus 6. Okay, what is our goal? Our objective is to get x by itself. Is x by itself? No. Here is x. Now we're back to step number 2, reverse PEMDAS. I need to get rid of pluses and minuses first. I see a minus 6. I need to get rid of a minus 6. How do I get rid of a minus 6? I'm going to add 6, both sides. Again, best part, crossing things out. 6 plus 6 is 12. However, I have 6 plus 7. That is 1 more. So that means I have 13. I have 7 here, and I have x here. So now, we've done a lot of work. Are we done? Did we get x by itself? No, x is still not by itself. X is attached to 7. How are they attached? They are attached by multiplication. So how do I undo times 7? The opposite of multiplying by 7 is dividing by 7. So I'm going to take my original 7. Here's my original 7. Here's my original 13. Here's my x. I'm going to take my original 7 and I'm going to divide by 7. Here's my dotted line, kind of running out of dots there, but here's my dotted line. Make sure that you are doing this on both sides and on different sides. Don't be doing the same step on the same side. 7, go away 7. That goes away. X is left over. I have x here. 13 divided by 7. I can't simplify that. 7 times 2 is 14. So I know it's close to 2. It's 1 point something, but I'm going to leave it as a fraction, and that's okay. Did you guys see that? I almost made the mistake again. I put that dot, but however, I'm going to erase it. Because we don't have an equation, we have an inequality. Did we multiply by a negative number? Anywhere in my steps, did I multiply by a negative number? No. Did I divide by a negative number? I did divide, but is this 7 negative? Did we divide by a negative? It has to be a negative, or you keep it all the same. Because 7 was positive, we keep the sign the same. So I'm going to take my original sign, which is a less than sign, and I'm bringing it down here. Is x alone? Yes. Did we reach our goal? Yes. Here it is. And we have our sign. Now, how would you graph something like this? This is a fraction. How would you graph this? So I know, here's my thinking bubble, because this is how I'm thinking. 7 times 2 is 14. I don't have 14, I have 13. So I have a little less than 2. Because 7 times 2 is 14, but 7 times 1 is 7. 13 is much closer to 14 than 7 is to 13. So I'm going to do a number line again. So I want 7 times 1 is 7. So 13 is here, closer to 14. So that means I have to be closer to 2. So here's 1, here's 2. I am somewhere here-ish. Okay, I am close to 2, but I am not at 2, but I am further away from 1. Now, let's translate this. This is 13/7 is less than x. So that means 13/7 is less than x. X means, another way to translate it, x is bigger. Do you see how the alligator teeth are pointing towards x? The alligator teeth want to eat the bigger thing, right? So if x is bigger, that means our arrow has to go towards the bigger numbers. So which direction are bigger? And that is, direction is to the right. Now, do we shade this circle in? Do I have anything here? I don't. I don't have my or equals. So then that means my arrow is, my circle is open and we are done with our number line graphing. All right, beautiful people, we are going to be doing a lot more examples in class. I hope this video has introduced you to inequalities. If you have any questions, write them down so we can talk about them in class. As always, I appreciate your time. Thank you so much for watching this video, and I will see you in the next one.